Hello everyone, my name is Raj Patel from Aerospace section. Today my topic is the torsional stresses and strain. Torsional stress. Shear stress. Shear stress produced when we apply a twisting moment to the end of the shaft about its axis torsional stresses. Torsion is the twisting of an object due to an application torque. In sections perpendicular as the torque axis, the resultant shear stress in the section perpendicular to the radius. Here, this is a diagram of a torsional stress. At, they are moving of the axis right to left. Torsion. Torsion is the twisting of a straight bar when it is loaded by twisting moment or torque that tend to produce rotation about the longitudinal axis in the bar. For instance, when we turn a screwdriver in these sites, when we turn a screwdriver in to produce torsion, our hand applied torque T to the handle and twist the shank of screwdriver. Here we can show about this screwdriver in these sites. Let us now considering a straight bar supported at one end act upon by two pairs of equal position force. Then each pairs of force P1 and P2 form a couple that tend to twist the bar about the longitudinal axis. This perpendicular surface transaction moment here is a P1 and P2 depth D1, D2, the axis of P1, P2 of bar. Okay, this is a torsion stress. Then the formula of torsional stress T1 is equal to P P1 D1 into T2 is equal to P2 D2. That moment, the producer of twisting of bar says that T1 and T2 are called of torque twisting moments. So here T1 T2 is equal to torque and P is equal to P1 P2 is equal to force, D1 D2 is equal to distance. Okay. Torsional stress of circular shaft. Interested in stresses and strain of circular shaft subjected to twisting couple or torque. Turbine experts torque T on the shaft. Shaft transmits the torque about the generator. Here we can source about the turbine axis and generators. Here is a linking formula twisting generators. When we use of a linking formula, the generators in A and B are will decrease. So generator created in the equal to opposite torques of T. Net torque due to internal stresses. Net of the internal shearing stresses in a internal torque equal to the opposite applied torque. T is equal to integration of rho df, then is equal to rho t dA. Although the net torque of the due to shearing stress, the net torque of the shearing stress is know that a distribution of the stress is not. So here, distribution of shearing stresses is statistically interdetermined must consider of subdetermined. Unlike the normal stress due to axis load, the distribution of shearing stresses due to torsion loads cannot be assumed of uniforms. So this is a formula of T is equal to integration of rho df is equal to integration of rho t df. Torsion strain. We have already discussed about stress. Now we discuss about torsional strain. So what is a strain? So here, torsional strain is a eclipse strain is the increase in potential energy of the molecule due to repelling between electrons in bonds that do not share atoms. Considering of two conformation of atoms, the smallest diagonal angle is 60 degree in one. It's a 0 degree in two. There's two CH bonds not sharing of carbon atoms that are closest to each other. CH1 and CH4 are closer in second than in one. The repulsion between electrons in the bonds do not share about carbon atoms, therefore greater than 2 than in 1. Consider torsional strain is a greater than 2 in 1. So now we discuss about torsional stress and strains formula. So see, this is a diagram of the torsional strain inside round circle. Since the stresses are acting consistently, they have a resultant in the form of moment. The moment of the smallest elements dA located at a radial distance rho and is given by dm is equal to tau max by r rho square dA. We saw the pictures. The pictures will be some blurs are there, but we understand that the resultant moment is the summation over the entire cross-sectional area of all such elements moment. T is equal to integration of a dm minus rho tau max by r integration of a rho square dm minus tau max by r ip. Polar moment of inertia of circular with radius r diameters I is equal to pi r raised to 4 by 2 minus pi d raised to 4 by 32. And the maximum shear stress tau max is equal to ta- tau r by ip minus 16 tau by 16 t by pi d cube. Now we discuss about a small numerical problems related to topics. So a solid steel bar of circular cross section diameter d is equal to 1.5 meter, I is equal to I is equal to 1.54 inch, G is equal to 11.5 into 10 power 6 psi. The bar subject to torque T, acting ends of torque magnitude T is equal to 250 IV. So, what will you find? What is the maximum stresses in the bar and what is the angle of twist between ends? So, here first of all, we draw about one torsional stress, torsional steel, solid steel. The diameter D is equal to 1.5 here, and the length is 54 inch. So a form torsion formula tau max is equal to 16 t by pi d cube. Here t is equal to 250 into 12 and d value is equal to 1.5. So substitute the value. So 16 into 250 into 12 by pi into 1.5 cube. The answer will be 4530 psi. And the angle of twist. So we will found about the angle. So IP is equal to pi d raised to 4 by 32. Substitute the value in a formula. So the answer is a 4970 inch square and phi is equal to tau L by GBI. So after substituting that value, we will make found about one of angle, stress and strain analysis. A shaft of circular cross section subjected to a torque at position and consider. A point in the cross section at the coordinates x3 will be rotated in the angle of theta x. So displacement given by ui is equal to minus theta x2 x cube and u2 is equal to theta x1 x3. So summation ij is equal to 0 0 minus theta x 0 0 minus theta x cube 0 0 minus x1. This is a one matrix and summation ik is equal to 1 by 2 rho rho ui by rho uk plus rho uk plus rho xi. Okay. So that torsion doesn't result in the change in the volume, it implies pure shear diffraction. From Hooke's law, summation ij is equal to lambda theta ij sigma k plus 2 mu e ij. Well, lambda and mu are the Lamb's constants and mu equal to g are modulus of rigidity. Here, constant of stress strainer summation ij is equal to 0 0 minus 0 theta. Here this is one also one of matrix. Okay. So we'll discuss about torsional stress and strains. Thank you.